In this video, we're going to be looking at calculating probabilities from a normal distribution by hand and then also normal distribution by a graphing calculator. In this chapter, the focus of it is going to be on continuous probabilities versus the discrete. So just to begin with, we're going to be looking at a continuous random variable x, and x can be any real value. So x can be decimals, it can be fractions, it can be any possible thing. Therefore, a function is used to specify that probability distribution, and that function is called the probability density function. Those probabilities are found by calculating the area under the probability density function over a certain interval. So we're going to be looking at curves. This gets into the calculus feature of it. We will not be looking at the calculus part of it. But if we were to actually physically be calculating this by hand, you would be doing some calculus features. Instead, we're going to be looking at a table to help us do it by hand, and then we are also going to be using our graphing calculator because we will be able to figure out how much exactly falls within that region when it's not perfect standard deviations away. We'll also look at those perfect standard deviations that we saw a little bit with our normal curves a little while ago. So to begin with, we're going to look at those normal distributions. These are the most important distributions for continuous random variables. If we can look at a normal distribution, that bell shape, we can actually figure out what the equation for it is, which is here. And what we're going to look at is for every member of that bell-shaped curve, there are specific parameters. We are going to be looking at both our mean and our variance, which is our standard deviation squared. If that's the case, then what we can say is that x is normally distributed by parameters of a mean and that standard deviation squared, or we call it that sigma. So different things that'll fall under this category would be looking at like physical attributes. For instance, a person's height. You have a whole range of heights. You are not just 5'8", you are not just 5'9". You're in between there as well. Looking at arm lengths, weights, etc. Those physical attributes will range in values. Looking at the test scores of a huge population, they can fall all over the place. It's not just a certain number that can happen. All of those different things just continually keep going through versus a discrete scenario where you're talking about number of desks, number of people, things that you can physically count. This is going to be a range of values. So some characteristics of the normal probability density function. The curve is symmetrical about the line x equals that mu, which is your mean. So we have this nice, beautiful little curve, and it's symmetrical about the mean. The mean always falls right directly in the middle. And 50% of your data is going to be on each side of that. As x approaches infinity, so as x is getting really, really large, or negative infinity, really, really small, it approaches the asymptote, which is that x-axis. It's always going to be greater than 0. No matter what, that y value will never drop below the x-axis. The area under the curve is 1. If I add all of those up, think about what we're finding. We're finding the probability. It either happens, doesn't, or somewhere in between. And then more scores are distributed closer to the mean, which is why we get that shape in the bell. It spikes in the middle, and then it slowly tapers off. So this is, again, a normal probability density function. Continuing a little bit more, if we are to look at the perfect case, standard deviation talks about that horizontal distance from the vertical line, where x equals my mean, to a point of inflection. So as that graph is kind of turning points around. So, slide this down a little. Here are all of my percentages. 68.26% fall within a standard deviation above and below, which is why in the past we talked about it being 68%. It's actually 68.26. We rounded a little bit more. 95.44 actually fall within 2 standard deviations above and below, and 99.74 fall within 3 standard deviations above and below, which is part of the reason those ends are actually 0.13, not 0.15, I think is what we kind of looked at early on, just based on rounding factors. So keep that in mind when you start looking at what falls where. Also, a huge important part is from here up is 50% of the data. From here down is 50% of the data. It's completely symmetrical. So if I'm finding from this region up, it's exactly the same as finding from this region down. Keeping in mind some of those symmetrical pieces, because our calculators and tables will only give us information one certain direction. So we will have to think clearly about that in order to determine what is the actual probability that I'm looking at. This wonderful picture will be super helpful for you when you start working on those cases. So starting off with an example. So we're looking at the chest measurements of 18-year-old male football players are normally distributed with a mean of 95 centimeters and a standard deviation of 8 centimeters. And then I want to find the percentage of football players, etc. So if this is the case, the first thing I'm going to do is I'm going to draw a picture. So here's my picture. 95 was my mean. I put that in the center. 1 standard deviation away was 8 centimeters, so I did within 2 standard deviations on both sides, keeping in mind my percentages. So with this, because I know my exact standard deviation, I can ask questions specifically dealing with those exact standard deviations. So in this case, in part 1, I actually asked 1 standard deviation away on both sides. So if you remember, this inside piece is 34.13, 34.13. This next part is 13.59, 13.59, just kind of keeping in mind, again, these are percents. Sorry, my diagonal numbers. So if I want from 87 to 103, I end up having 68.3. If I round that up, 68.3% of my football players fall within that region there. Now if I look at from 103 up to 111, that's between 1 standard deviation above and 2 standard deviations above. So that's 13.6%, 13.59, rounding it is 13.6. So then find the probability that the chest measurements of a randomly chosen football player is between 87 and 111. So now I'm just adding up all of the different cases from 87 up to 111. So it's the 68.3 plus the 13.6. So 81.9% of all football players fall within 1 standard deviation away up to 2 standard deviations away. The last part of this talks about finding the value of K such that 16% of the measurements are below K. So now I'm giving you the percentage, and I want to find what the number is. So now I'm kind of going in the reverse order of what we've done before. So now with my picture, I want to figure out where does K have to be so that 16% of the folks are from that value down. So if I need to look at 16%, I know that half my folks fall from here down. And then if I go 1 standard deviation away, this is again about 34%. So therefore, from 1 standard deviation down is about 16%. So the value that's going to be at 16% and below falls at 1 standard deviation away, and 1 standard deviation away was 87. So my K value is going to be right around 87 centimeters. So 16% of chest measurements are below 87 centimeters. So again, that's going backwards. Here's your percent. Now go backwards and find the value there. Then we're going to look at using our calculator. So now suppose X is normally distributed with a mean of 10 and a standard deviation of 2, because remember it's comma 2 squared, standard deviation squared. So what I just said is what's listed there. So now what I want to find is I want to find the probability that X is greater than or equal to 8 but less than or equal to 11. In order to do this, I'm going to draw a picture. Pardon my not perfect bell. I know my mean is at 10. Standard deviation is 2. So that's up to 12 and down to 8. And I could go 2 standard deviations away, so up to 14, down to 6. However, in this problem, I want X greater than or equal to 8. Fantastic. I have my 8. But then I want it less than or equal to 11. I don't have that. I have to use a calculator, or in the next video, you're going to learn how to use what's called a table, is what we're going to look at. So in order to do this, I have to go to my graphing calculator. This is a nice normal bell curve. That's why there's the N there. If I'm finding a range of values, what I'm going to be punching into my calculator is as follows. I have to find my normal CDF. And then it's going to be the starting number, which is 8. It starts at 8. So this is the start, comma, I'll come back to that one in a minute. My end number, 11, comma, the mean, comma, standard deviation. That's how we're going to plug it into our calculator, and it is going to give me the probability of x being greater than or equal to 8 but less than or equal to 11. So in my calculator, I have to find my normal CDF. So this is a distribution, so second and then vars is my distributions. And then I need a normal CDF, which is number 2. So now when I'm looking at this, it's 8, comma, 11, comma, 10, comma, 2. And if you look at my little calculator, you'll be able to see it. The other one cuts off the screen. And then hit enter. And that is not what I wanted. So I lost my negative. So we'll just clear that out and start over. Sorry about that. Okay, clear. So second, vars, normal CDF. Let's make sure I don't miss anything this time. 8, comma, 11, comma, 10, comma, 2, close your parenthesis, hit enter, and now I get it. So it's 53.28, etc. So that is my probability. So when I punch this into my calculator, I get 53.3%. So 53.3% fall within that range. Now, if you kind of keep in mind where we're looking at, we're looking from 8 until 11. We're not going up to 12. If I went up to 12, then I'd have about 68.3%. So it has to be less than 68.3%, but it's more than just one standard deviation in one direction, and one standard deviation in one direction is the 34.13. So you kind of think about it logically, make sure that it makes sense, the value that you're finding. The second part to this question is now looking at finding A if I give you the probability. So now I have to work backwards. To work backwards, we have to find the inverse of a normal distribution. So in our calculator, we have to look for inverse norm. So INV-NORM. And what I'm going to do in my calculator here is I'm going to be putting in first my probability, 0.479. That has to be the decimal. So this is the probability, comma, the mean, comma, the standard deviation. So this will give me where that A value is going to be. So what I'm trying to do is on my normal curve, I need my probability to be 0.479. So if I think about it, halfway is 50%, so I want it just under that. So I want from there down. So I want all of this region. So it has to be less than 10 because my mean was 10. Again, think about them logically as you're doing them. So to find this, second, vars, going into that distribution again, inverse norm, number 3. First one is your percent, 0.479, comma, mean, comma, standard deviation. And it gives me 9.89467, etc. So this gives me 9.89, which should make sense. It just has to be below 10 because it's just less than 50%. So we just looked at finding our probabilities for continuous using normal distributions by hand and then on your graphing calculator.